Welcome to Rges Algebra 2. This is lesson 11A, and it's on your section 215, Applications of Factoring, Solving Equations. So I'm going to label it Solving Equations by Factoring. So let's say we have an equation and the first thing you notice, hopefully, is that you do not know how to solve equations yet with a squared term. So far, all the equations you've solved have only x to the first power. So there is a technique that allows you to do this by the process of factoring you've already come to understand. So first off, what I'm going to do is take everything to the left side. We call this setting the equation to 0, meaning the right side of the equation will be 0. So then we get x squared minus 2x. We're going to combine the 1 and the 16. So we're going to get 1 minus 16 or minus 15 equals 0. Now, if and only if this equation or this expression on the left-hand side can be factored, then you would know how to solve this equation. Let me show you why. Can I factor it first off? Well, a 3 and a 5 make 15. They have opposite signs. And if I make the 5 larger or negative, make the larger number negative, then what would I get if I checked it to go back? With FOIL, I would get x squared minus 5x plus 3x. That would be negative 2x and minus 15 for my last terms. So that is true. Okay? Now, let's look at this in a very broad idea. What I really have over here is something, and let's not use an x, something like an a, an expression, times something else equals 0. If I'm trying to make this equation here on the left, very general, I'm saying something times something equals 0. Well, there are only a few conditions that allow me to get a multiplication that ends with a 0. Something times something equals 0. Well, 1 times 1 does not, 1 times 10 does not, 1 times 100 does not, a negative 3 times a positive 3 does not, a negative 3 times a negative 3 does not. What is the only condition that allows me to multiply two things together to get 0? And the answer is one of them must be 0. So either the first group or the first term being multiplied, either A or B, must be 0. Or both, but just one of them has to be 0. So is that true? Let's see, a negative 3 times 0, that equals 0. If I have A equals 0 and B equals 27, that still equals 0. So whether A or B equals 0, the answer will be 0. So I'm going to apply that knowledge over here on the left. Either this, we could call that my A, must equal 0, or this must equal 0. So let's do that. Either x plus 3 must equal 0, or x minus 5 must equal 0. In order for the product, when I multiply them together, to get an answer of 0. So just solve each of these mini little teeny equations. X equals negative 3 or x equals 5. And now you've solved it. Go back and plug it into the original equation, and you will see that putting in either of these, and I will get 0. Okay? So that's how we solve an equation using the method of factoring. Now we can also solve an inequality using the method of factoring. But before we do that, I'd like to do another problem. Let's work this. Take everything to the left, so we set the equation to 0. It means that we make the equation equal to 0. See if I can factor. See, a 3 and a 9 equal 27, but I've got this 2x up front, making it a little more complicated. Let's see, can I still do it? Well, if I do a 2, line up that would be 18, and let's see, we got, 3 and 9. There we go. We could have a 9 and a 6. That does not give me a difference. Or I could have a 18 and a 3. That would give me 15. Well, I'm struggling a little, and then I look back and notice that I did not copy the problem correctly. So let me fix all this and start again. All right, now we'll set this equation to 0. That might make a big difference. Hopefully it will. Minus 28 equals 0. Let's catch my common factor of 2. Always look for the common factor. Two numbers multiplied together to give me 14, That would be a 2 and a 7. And their difference is 5. So let's get all that. Don't forget to carry down your common factor. Sometimes you're forgetting that. So we'll have an x and an x, a 7 and a 2. Or we want a positive 7 and a negative 2. Check back just the FOIL part, and you'll get x squared minus 2x plus 7x. That would give me plus 5x. 7 times a negative 2 would be negative 14, and that works fine. Now, the constant doesn't matter. If I had 2ab equals 0, either the a or the b had to be 0. So let's write that out. Either x plus 7 equals 0, or x minus 2 equals 0. Solving, we would get x equals negative 7 or x equals 2. Now, when we're dealing with an inequality, things get a little messier. Not too bad, though. Let's go ahead and see if we can factor it. A 4 and a 1 will give me a difference of 3. My 4 will have to be negative, and this will be positive. Factor back. Make sure everything's good. You're going to get x squared plus 1x minus 4. That'd be minus 3x minus 4. Okay, so we factored correctly. Always check that factoring. Now, what do I do at this point? Well, I'm going to go ahead and solve, and I'm going to get x equals... Well, I guess I'll write it out just as we have been. Either x plus 1 is greater than or equal to 0, or x minus 4 is greater than or equal to 0. Now, actually, let me just back up here just a minute in my explanation. Okay, what I really want to suggest is that we change this for the purposes of the solution set to an equal sign. We'll come back, okay? But this really makes more sense mathematically. Solve these so we get x equals negative 1 and x equals 4. And now there's another step to the problem when you have an inequality. On a number line, here's my 0, you're going to plot negative 1 and you're going to plot positive 4. Okay, approximately up there. Now, these are the 2 points at which we will, they're called the zeros of the polynomial. They will make the equation equal to 0. So we have to decide what's going to be happening in between those two. Is it going to be greater than? Or what's going to be happening in this region, what's going to be happening in the region between, and what's going to be happening in the region over here. We want to know, are those values going to be greater than, okay, or less than? All right, so let's choose a number like -2 and plug it in. Plug it in back to the original equation, and we have to decide, is it going to be greater than, now I guess I should not have changed that equal sign to there. Let's leave it in its proper form as it was given to us in the original equation. There we go. Plug this back in here, and we're going to get 4 plus 6, that would be 10, minus 4. 10 minus 4 is 6. Is 6 greater than or equal to 0? And the answer is yes. Okay, so the statement is true here. Okay. Now let's plug in something in this region. Let's plug in 0. I like to work with 0 because it's easy to do the multiplication. 0 minus 4. Is -4 greater than or equal to? No. Okay. And let's plug something in over here. I don't like large numbers, so I'll take a 5. We got 25 minus 15, that would be 10. 10 minus 4, that would be 6. Is 6 greater than or equal to 0? And the answer, again, is yes. So how do I interpret this? X has to be less than or equal to, because it can be equal to the 0 up in the original equation, has to be less than or equal to -1, because this is the good region, and this is not a good region, so it doesn't want to be there in the middle, but this is also a good region to the right, or X would have to be greater than or equal to 4. So we've solved for our 0 points, just as you would an equality. Then you look at your number line and you plug in to decide which region is true. Would it be the region in between or the region to the outside? And in this case, it's the regions to the outside, so this is my answer. Okay. So we'll play with a couple more of those in class and discuss that further. Be sure to ask me. Your check for progress 1 and 2, you should be able to do on your own. I will warn you from the quiz that you do need more review to completely factor. So I would suggest you take some problems in 214 and do those also perhaps for additional practice. But whatever you do, let's get a little more practice in there on factoring, because you will not be able to do this last step, and factoring is one of those key concepts that will be used again and again and again, and definitely in the next section. So please master it before we move on.